Hello children. We are starting with applications of derivatives. This is the last chapter of your volume number 1 book. In this applications of derivatives, we are going to look into the applications of differentiation in various ways. How all we can do. If I tell you the chapter names, you will understand like how all we can use uh, differential calculus. See, the first chapter is rate measure. Then second one I'll keep tangent and normal. This is exactly not second one in your textbook, but I'll do in this way. So tangent and normal, and then we have approximations. Then we have increasing and decreasing functions. Increasing and decreasing functions you have, which is a very important part of mathematics. Fifth one is maxima and minima. Maxima and minima. Now children, in this, for your PU board examination, second PU, in second PU, like in the question paper, final exam paper, from rate measure, 1 5 marks is compulsory. The rest others you'll get 1 mark, no, 1 2 marks, 1 3 marks, you'll surely get. Okay. And for CBSE syllabus, maxima minima will be very important for CBSE syllabus. Now, since I'm connected to you with this PU board, I'm telling you that this is important for A marks. And then when you look into the applications of differential calculus, you see you have something called as a rate measure. What do you mean by rate? Okay, night you are going to put a little of bacteria into the milk, and morning you see it has become curd. So at what rate the bacteria has increased? Or at around 2 o'clock, 2 p.m., what is the number of bacteria that you have? I think I told this example priorly. Okay, if not this, if there is a certain kind of reaction that's happening in chemistry that you want to find out, you can find out the rate of reaction priorly, or what is it after putting the catalyst inside the solution. How is the rate of reaction happening? And what is the rate of reaction between compound number 1 and compound number 2? And what about the reactions rate of reaction between the other two compounds, etc. This is about in chemistry. When coming into physics, you can see every day in day-to-day life, you can see that this physics is applied everywhere. Construction of bridges, construction of buildings. You can see nowadays construction of buildings in various ways. Okay. Now, for all this construction of buildings, they without having your mathematical calculations and the differential calculus of mathematics, you can never construct anything, not even a road. If you want to find out what kind of inclination the road needs, also you need trigonometry. You need differentiation. Okay. And when it comes to increasing and decreasing functions, how is the function, where is the function increasing, where is it decreasing? And if it is increasing, how am I going to find out whether it is increasing or not? And not only that, like this maxima and minima, these two are like very useful in many scientific fields. Maxima, minima, how am I going to get the highest uh, in what, even in stocks and shares they use maxima, minima. Whenever I'm having revenue, if I have to find out the marginal revenue, I will have the total cost. Okay, I will have the total revenue. If I have to find out the marginal revenue or marginal cost, then I have to differentiate it. If I differentiate it, then I'll get to know per unit what is the cost. Average, it's like taking the average. Similarly, revenue. total revenue is so much. So when you come to every person, what is the revenue of Karnataka, or what is the revenue, average revenue of a person in India, you want to find out, then you have to do differentiation. Or approximately, if I give you in Karnataka revenue is so much, in Assam it's so much, in Gujarat it's so much, in Kerala it's so much, in New Delhi it's so much, and if I have to accumulate everything and tell the total revenue what is it for the entire nation, then I have to do integration. Okay, so that is, if I give you marginal revenue, you can integrate and find out the total cost. So these two are like reverse process. So now this application can be found in everyday life, everywhere. And what is this approximation? This approximation is very much necessary in all the developments of the equipments of army defense, in all the defense equipments. And not only this, if you want to make very minute, it should be like the instrument has to be accurate to, it should be precise to every decimal, where you want to do for garment industry, or for any cutting industry, finishing industry, where you do all the cutting and finishing things for this, in machinery products, then you need this approximations. It should be, there should be, what is the error, what kind of error is occurring, where is that we are slow, and what should be done to find out the increasing of the functioning of the machine. You need to apply differential calculus. Now this is how differential calculus is very much applicable in our day to day life. Now coming to the very first chapter, rate measure, I told you rate measure is the increasing or decreasing of the rate of functioning of anything. So it may be rate of increase of water flow into a cylinder, or it may be the sand which is coming pouring out of the lorry and coming as forming as a cone, or it may be you are using a spear and where you pump in some gas inside the spear, and how far it is it how is it increasing, in what rate it is increasing, to what extent it has to increase so that you can leave the balloon to the air. Now all this to calculate, we need something called as rate measure. So in rate measure, not only the live examples what I told you now, it is about movement of vehicles also, which is very much useful. Okay, so in rate measure, now let me start giving you some synopsis where I need all the formulae uh, regarding displacement and also some 3D figures. Now point number one, if S is displacement, if S is displacement, and this point you must have already learnt in your physics, velocity v is equal to ds by dt, and then acceleration a is equal to, you differentiate this velocity, you will get acceleration d square s by dt square. It is also equal to dv by dt. I told you velocity, if you differentiate, you will get acceleration, that is double time differentiation of the displacement, you'll be getting acceleration. Okay, now if I say particle stops, when will a particle stop, when will the vehicle stop? And particle stops are, I'll say you have applied brake. If you find such sentences, such phrase words, applied brake, then what happens? The particle will stop, the vehicle will stop. And if the vehicle is stopping, what is the meaning of that? That means velocity has become zero. Velocity, velocity at initial velocity is equal to zero. Particle stops. Okay, velocity becomes zero. So let me tell initial velocity in a different way. Initial velocity, what do you mean by initial velocity? That is even before you start moving. Okay, what is the velocity? So velocity at t equal to 0. When time is 0, it is not even moving the vehicle and you have started. So what is the velocity that you are giving? That is initial velocity. And what do you mean by uniform acceleration? Uniform acceleration. When do you use accelerator, children? What will happen to the vehicle if you put the accelerator? If you accelerate it, it goes faster, right? Or if you decelerate it, if you want to lessen it down, you'll decelerate it. So that is what is this? So uniform acceleration. I don't want that accelerating thing to happen. Then what should happen? The velocity should be continuous as it is. The speed should be in the same way. There should be no uh, what Oh, I should not say uniform acceleration, children. I should be telling what? Uniform velocity, right? The velocity has to be the same thing. Acceleration should not be there. Oh, I made a mistake. So uniform velocity means there should be no acceleration. So A is equal to 0. You should not give the accelerator at all. If you don't use the accelerator, the velocity of the vehicle will be in the consistently in the same measure. Okay, now these are some things what I had to tell about rate measure with respect to displacement. But when it comes to your NCERT syllabus, you don't have the displacement problems. So now I'll come to the 3D figures and the 2D figures, starting from square. For square, you have area is equal to x square and the perimeter is equal to 4x. And we have rectangle. Rectangle area is equal to x into y, where I am taking x as the length and y as the breadth, or vice versa. It's length into breadth. And what is its perimeter? Perimeter is 2 into x plus y. Okay, after rectangle, next square, rectangle, let me talk about circle. For circle, we know diameter is equal to 2 times radius, circumference is equal to 2 pi r, and area is equal to pi r square. After circle, next I'll go to cube. Cube, volume is equal to x cube and surface area is equal to 6x square. There are 6 faces in the cube. Every face is a square, so it is 6x square. Next is let me take sphere. Sphere volume is equal to 4 by 3 pi r cube, whereas surface area is equal to 4 pi r square. 4 circles make one sphere. Surface area we always give by the letter S. That's sphere. Next, I'll say cone. Cone only volume is enough. 1 by 3 pi r square h. Okay, now uh, these are the formulae that we use and the figures that we talk about in general. And if there is any other point which I'm telling in between something important, you can come and pile it up here. And I'll tell you this also. They would have given you total cost, so I'll write marginal cost. Marginal cost is differential of total cost. Total cost. And then after marginal cost, I'll also write in the same way for marginal revenue. Marginal revenue is equal to differentiation of total revenue. Okay, if you know this much, you can do the entire chapter, entire exercise by yourself after I do some 3 or 4 problems. But of course, I do the entire exercise except few 2 or 3, whichever I leave. Please make a note of whatever I'm not doing and see that you'll get the answer for that. Okay. Now these are all the formulae that we are going to use for the first topic under application of derivatives, that is rate measure. So next I'll go to the exercise problems. We'll start up with the exercise problems. Yeah, here it goes. The question number 1, exercise 6.1, and this is a problem regarding circles. See, we're talking about area of the circle, and in every question, whenever they say rate, it is always with respect to time. So the very first point, what do you mean by rate? Rate, it will tell you that it is with respect to time. It's always the measurement with respect to time. But I may not do with respect to time all the time. I'll do, it is by default that we always do with respect to time until and unless they tell us with respect to what I should do. Okay. So here in this particular question, they have asked us to do with respect to the radius. See, I want the rate of change of area. With respect to what? With respect to its radius. So I need to find out dA by dr. rate of change of area. Area comes in the numerator. With respect to whatever you have, that comes the denominator, and that is r. So whenever I say with respect to time, rate, we say it is d by dt, where t indicates time. Alright. So other than time, if they ask you specially like this, like exclusively with respect to something, sometimes it will be with respect to circumference, with respect to radius, but most of the times it's always radius other than time. So let us come back now. I will come to this question here. This kind of question they have given with r equal to 3 centimeter, 4 centimeter in the exercise. Other than that, there is one worked example where they say r is equal to 5 centimeter, and there is one objective where they say r is equal to 6 centimeter. So I shall do for any two numbers, the rest two you do by yourself. Let us start now. So find the rate of change of area dA with respect to radius. dA by dr is equal to question mark. When at r equal to 3, at r equal to 4, at r equal to 5, r is equal to 6. I'll call this as A problem, B problem, C problem, D problem. Okay, and now I'll come to area of the circle. Area is equal to pi r square. I know area of the circle is pi r square, and I need to do the differentiation with respect to radius. So dA by dr is equal to pi into 2r. That's it. If it is with respect to time, I should write dA by dt. Area will be changing as well as radius will be changing with respect to time. I should have written dr by dt. But now I am not writing because we are doing the differentiation only with respect to, we are finding out the rate only with respect to what? The change in the radius. So it is dA by dr, 2 pi r is the differentiation. Now problem A, dA by dr when r is equal to 3. It is 2 pi into 3, which is equal to 6 pi, and we're talking about area. So it is centimeter square per second. Okay. I have taken per second, or maybe per whatever. I have taken per second. Next, B. The same thing when r is equal to, 4 centimeter, how much is that? It is 2 pi into 4, which is equal to 8 pi centimeter square per second. When r is equal to 4 centimeter, area is increasing at the rate of 8 pi centimeter square per second. That's the meaning. Okay. Now for 3 and 4 I have done. For 5 and 6 you do by yourself. We'll go to the next problem, and as I do second and third, you'll get an idea how to write the data. Writing data for application of derivatives problems is very, very important, because you should know what is your goal. What have they given? What is it I want? What is it they have asked for? We got a question number 2. The radius of a circle is increasing. You know what? In your exercise, you have haphazardly combined questions. They're jumbled up. The questions are jumbled up on various figures. I have put all circles in one place, all cubes in one place, and all sphere problems in one place, so that we will have a good flow. The second question is, the radius of a circle is increasing. Okay. Radius, what is increasing? What is increasing? Radius is increasing. So I'll write dr by dt. And in case they have told with respect to radius or something, then only with respect to area or something like that, then only I'll say dr by dA or something. But then this is the least parameter in the circle. Is it not? Circle is defined on radius. So it has to be with respect to time only. Radius of a circle is increasing uniformly at the rate of 3 centimeter per second. So dr by dt is equal to 3 centimeter per second. Find the rate at which area of the circle, find, what should you find? Rate of area of the circle. So dA by dt is equal to question mark. When is increasing, when the radius is 10 centimeter, when r is equal to 10 centimeter, what is the issue? Okay, so let us start now. We have got, it's a very small problem. They have given the numerical value for radius, and I want, it is questioned about area, so start from area of the circle. Area is equal to pi r square. and we'll differentiate it with respect to time. dA by dt is equal to pi into r square. Differentiation would be 2r into dr by dt. And in this dA by dt they are asking when r is equal to 10 centimeter. So I can plug in r equal to 10. dr by dt they themselves have given that it is equal to 3. So now we'll do dA by dt at r is equal to 10 is equal to 2 pi into 10 into dr by dt is 3 is equal to 2 3s are 6, 6 10s are 60 pi square centimeter per second. Writing the unit is very important, children. Write the unit and highlight your answer. The way you present your answer, especially for the application problems, is very important. So bifurcate you make your page into two parts. If there are two different parts, show that very compactly side by side whatever the answer you have got. Because one statement problem will have two or three parts where they can give the marks, allot the marks for you, one, and so on. Especially in PO board when when the correction is done, we get the scheme of valuation, and they will give us where all have to give one and so on. Of course, if the entire problem is at a stretch, when we get to know it's everything is correct, then I'll put 5 as such. Okay, so rate measure is going to come for how many marks? 5 marks. So the steps will be allotted one, and so on. The last answer, declaration of the answer will have 1 mark. You will get that last 1 mark only if and only if you have written this unit. So even if you have written 60 pi and you have not written the unit, you will lose your 1 mark. So be particular about writing the units. And next we go to the next circle problem. See here they say a stone is dropped into a quiet lake and the waves move in circles at the speed of 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? So a stone is dropped into a quiet lake, so circles are formed. And when the circles are formed, they are telling the waves move at the speed of. So I don't know whether radius is increasing or area is increasing. According to us, when we imagine the waves that is formed in the pond when we throw the stone, it increases in such a way. For me, radius also is increasing, area also is increasing. I don't know to what I have to put this 5 centimeter per second. So let us go further and see what is it they have question for. What have they question for? They have question for uh, when the radius is of the circular wave is 8 centimeter, how fast is the enclosed? Okay, it's here. Enclosed area increasing. So dA by dt I am supposed to find out, which means that the previous unit what they have given, that is for radius. So dr by dt is equal to 5 centimeter per second, and they are questioning about the rate of increase of area. So dA by dt equal to question mark. When should you find out? When radius is equal to 8 centimeter. You have the radius here. The radius, when the radius of circular wave is 8 centimeter, how much is it? So now they have given radius numerical value. We'll start off with the area of the circle problem formula. A is equal to pi r square. dA by dt is equal to pi into differentiate radius also with respect to time. That will give you 2r into dr by dt. So now dA by dt when r is equal to 8 centimeter. So dA by dt when r is equal to 8 is equal to 2 pi into 8 into your dr by dt is 5. So what did you get altogether? 2 8s are 16, 5 8s are 40, 40 into 2 is 80 pi. 80 pi what? This is area. So it is centimeter square per second, or it is 80 pi square centimeter per second. Both are one and the same. So it's quite a small problem. We are looking into some 3 marks holdable questions. Okay. So now we'll go to the next question where you have radius of a circle once again. That's a circle question. Radius of a circle is increasing. Okay. What is increasing? Increasing. What is increasing? Radius. So I'll write dr by dt. How is it increasing? At the rate of 0.7 centimeter per second. So this is equal to 0.7 centimeter per second. What is the rate of increase of its circumference? dc by dt is equal to question mark. This is damn simple. There is nothing much. Circumference formula I'll put 2 pi r. dc by dt is equal to 2 pi into dr by dt. dc by dt, oh, there is nothing much to do. 2 pi into dr by dt alone I want, and you already have it as 0.7. So 2 sevens are 14, so it is 1.4 pi dc by dt. We are talking about circumference, which is the length, so this is centimeter per second. We got our answer. Okay, next, this is about circle. I guess we are finished with circle problem. Yes, we are done with circle problems, and now we are getting into the next figure, cube. Okay, cube question have been asked at least twice. Yes, so now this is a cube problem. So we are shifting from circle to cube. The volume of a cube, what is increasing? The volume is increasing. The volume of a cube is increasing at the rate of, so dV by dt is equal to 9 cc per second. Okay, what is that they're asking for? How fast is surface area increasing? ds by dt is equal to question mark. When the length of the edge, when x is equal to 10 centimeter. Okay, the volume of the cube is given to you, the rate of change of volume is given to you, and you have to find out the rate of change of surface area. So both volume and surface area depend on x, the edge of a cube. If they have asked only dv by dt, or if they ask only ds by dt, directly we'll get into that particular formula. Now you have to start from the formula for which you know the numerical value. What numerical value? Which numerical value have they given to you? They have given about volume. So let us start volume of a cube. Volume of a cube is x cube. We'll differentiate it on both the sides with respect to t. dv by dt is equal to 3x square into dx by dt. dv by dt numerical value is 9 that they have given. 9 divided by 3x square is equal to dx by dt. Now in this, if dx by dt, find the rate of change of edge of a cube had they asked, then you would have stopped at this place, and they would have asked x is equal to 5 or 10 or whatever, you will plug in x is equal to 10. But they have asked about surface area, not about the edge. So now I have got an expression 3 ones are 3 threes are. I have got an expression for dx by dt. In case if they have asked about the rate of increase of edge, then you'll plug in x is equal to 10 as they told, and you would have got the answer for the rate of change of the edge. Now they have not asked, so I'll keep the expression as it is to be plugged inside the surface area. So whenever they ask you about surface area, giving the information about volume, you will be shifting from volume to surface area. In such cases, please divide your page into two parts so that your presentation is very clear and they can understand that you have carried one part's result to the other part. So now let me start with the surface area of the cube. Surface area is equal to 6x square. Differentiating this, ds by dt is equal to 6 into 2x into dx by dt. Okay, so ds by dt at x equal to 10 is equal to what? But before putting x is equal to 10, let us write what is this dx by dt equal to. So 6 into 2 into x into 3 by x squared. 1x got cancelled. And then what is your, I'll put x is equal to 10 now. So you have 12 into 3 divided by 10. So 2 6 2 5 it's equal to 18 by 5. Okay, let me check. This is dv by dt, v is equal to x cube, 3x square dx by dt. dv by dt is given as 9. 9 divided by 3x square. So it is 3 by x squared for dx by dt. Surface area of a cube is 6x squared, 6 into 2x into dx by dt. So 6 into 2 into x into dx by dt is taken from this side. That is 3 by x squared. 3 by x squared, 1x is gone. So you have 6 2s are 12 divided by 3 divided by what? Sorry, 6 into 2 as 12 into 3 divided by x is 10. So we got 18 by 5. 18 by 5, if you want to write it as 3 point something also you can write, or else 18 by 5 what? It is centimeter square per second, because it is area. It is surface area. Okay, this is how you are going to do your problem about the cube, and when they have shifted from volume to surface area, be particular that you will present it very neatly, box your result properly where you have dx by dt, which will be used inside surface rate, okay, rate of change of surface area. Now exactly like this you have another problem. Okay, so now they're talking about volume of cube again. Volume of a cube is increasing at the rate of 8 centimeter cube per second. So volume of a cube is increasing. dV by dt is equal to 8 centimeter cube per second. How fast is the surface area? Here also. So we are shifting from volume to surface area. ds by dt is equal to question mark when x is equal to 12. When edge is 12, we are supposed to find out. So once again, we'll start from volume of a cube formula here. Volume of a cube is equal to x cube. Differentiating with respect to time, dv by dt is equal to 3x square into dx by dt. dv by dt is given to be 8. 8 divided by 3x square is equal to dx by dt. They have not asked about the rate of change of the edge. So dx by dt is equal to 8 by 3x square. Now let us start with surface area of the cube. Surface area is equal to 6x square. Differentiating, ds by dt is equal to 12x into dx by dt. So ds by dt at x equal to 12. Oh, once again I made a mistake. I want to substitute this dx by dt. So ds by dt is equal to 12 into x into what is my dx by dt is 8 by 3x square. 8 divided by 3x square. 1x got cancelled. 3 1s are 3, 4s are also. So I have got 32 divided by x. So now I'll write at ds by dt at x equal to 12 is equal to 32 divided by 12. So it is 4 8s are 32 and 4 3s are 12. So it is 8 by 3. 8 by 3 we're talking about surface area. So it is centimeter square per second. So this is, and if you can declare the answer with the statement as they have given in the question, that will be fantastic. Okay, correct proper ending of the statement problem. Now this is about the cube which was shifting from volume to surface area. We'll go to the next problem. There is another problem about cube, and here you see the edge of a variable cube, that is x of a variable cube, is increasing at the rate of 3 centimeter per second. Here directly they have given dx by dt which is 3 centimeter per second, and then they say how fast is the volume increasing. So dv by dt equal to question mark when the edge is 10 centimeter, that is when x is equal to 10 centimeter, what is the I have to find out what is the volume rate. So volume, only volume, parameter, the least parameter what you can, the formula of the cube will stand on edge, on x, is it not, on the edge of the length of the edge, that is x. So volume directly will put, we get only two steps, we get our answer. Volume is equal to x cube, dv by dt is equal to 3x square into dx by dt. dv by dt is given to be 3 divided by 3x square is equal to dx by Oh, I'm sorry. dx by dt is given. dv by dt at, I'll write dv by dt at x equal to 10 is equal to 3 into, so this is 10 square, that is 100, and dx by dt is supposed to be 3, so we got it is 900. 900, what is the unit? It is volume, so it is cc per second or centimeter cube per second. So it's only so much, it's very simple. And I guess we finished with cube, and we go to the next one. We have a rectangle problem here. This rectangle problem they have given thrice or 4 times. This rectangle problem is very simple but highly important for PU board final examination. As I told, now this is decreasing. We'll start writing the data. Here it goes. The length x is x is decreasing. Because it is decreasing, I should be writing minus 3 centimeter per minute. So be particular about this minus. And then they have given dy by dt is equal to 2 centimeter per minute. What is it I'm supposed to find out? I'm supposed to find out the rate of change of A, perimeter, B, area of the rectangle when x is 10 and y is equal to 6. So I need to find out dp by dt equal to question mark, dA by dt also equal to question mark, when x is equal to 10 and y is equal to 6. And we'll start. There are two different parts in this question. I'll divide the page. One side I'll do for perimeter, one side I'll do for the area. So the A part of the problem, perimeter of rectangle is given by 2 into x plus y. And since it is addition, you can do the differentiation directly. You have got dp by dt is equal to 2 into dx by dt plus dy by dt. And you have directly the what's that, the data what they have given. 2 into, what is your dx by dt? It is minus 3. What is your dy by dt? It is 2. What is 2 minus 3? It is minus 1. So it is minus 2, and we're talking about perimeter. So it is centimeter per minute. Minus 2 centimeter per minute. What does this minus tell you? Minus tells you that the perimeter is also decreasing in its rate. Change of the perimeter is decreasing. Then B part of the problem, we talk about area of the rectangle. Area of the rectangle is given by length into breadth, which is x into y as they have given in the question. This is a product. So you have to use product rule here. So I'll differentiate this. dA by dt is equal to x keep as it is. Y differentiation is dy by dt plus y keep as it is. X differentiation is dx by dt, and we have all the four data which they have given. So dA by dt at, I'll say dA by dt at x equal to 10, y is equal to 6, am I right? Yeah. So x is 10, y is 6, dy by dt is 2 plus dx by dt is minus 3. So I got 20 minus 18, which is equal to 2 centimeter square per minute. Yes. 2 centimeter square per minute. This is about the rectangle problem. There are two rectangle problems in your textbook. Soon after this, you have one more of the rectangle with the same given data. Okay, they have given dx by dt which is decreasing. They have given dy by dt which is increasing. Length is decreasing, width is increasing. So just replica of this problem except the difference in the numericals. So I will leave that as your homework. Question number 9 will be your homework, children, wherein this is dx by dt. Dx by dt is 5 centimeter. So this will be 5, and width y is increasing at the rate of, this is going to be 4, and they're asking the same thing when x is 8 and y is 6 itself. So it will be the same thing again, only these numbers will change. So dx by dt, I'll replace this minus 3 as minus 5 and this as 4. Once again you get the same answer. 4 minus 5 is minus 1. Minus 1 into 2 is minus 2 centimeter per minute. Next, coming to area, here area is going to x into y, the same differentiation. Now x is equal to this, not 10, instead it is 8. 8 and 6, then you have x is 8 over here, dy by dt. What is your dy by dt? dy by dt is 4 plus y is 6 of course, and dx by dt is minus 5. So what are we getting here? We are getting 32 minus 30. 32 minus 30. Once again the answer is 2 centimeter square per minute. I shall keep this as your homework, but anyway you have already the answer. I only have changed the numbers accordingly what we had done inside the problem, what we had done in the previous one. Okay, so now we are getting into the sphere problems. Okay, so now we are coming to this. We are coming to the sphere problem. We have a balloon which always remains spherical on inflation. What do you mean by inflation? Inflation is the balloon is becoming bigger. It is when it is becoming bigger, what is increasing? We feel that the radius also is increasing, surface area also is increasing, volume also is increasing. Out of all this, you should choose the bigger part which is increasing. So along with the radius and the area, the inner mass also is increasing. That is nothing but the volume. So I need to take about volume. So let us say dV by dt is increasing. Volume is increasing by how much? The rate is 900 cc per second. Find the rate at which the radius of the balloon is increasing. Dr by dt equal to question mark. Dr by dt is equal to question mark when what? When the radius is, when r is equal to 15 centimeter. So let us start off with the formula for which they have given the numerical value. They have given the numerical value for volume. So start, volume of the sphere is given by 4 by 3 pi r cube. dV by dt is equal to 4 pi by 3 into 3r square, dr by dt, 3 gets cancelled. And now it's very simple. I need to plug in r is equal to 15. So dV by dt when r is equal to 15 is equal to 4 pi into r square. 15 into 15 and dr by dt is given as dV by dt. Okay, dV by dt is given as, oh, I should have written here, is it not? dV by dt is given as 900. I'll bring this 4 pi r square to the other part. 4 pi r square is equal to dr by dt. Now I'll plug in r is equal to 15. So dr by dt at r is equal to 15 is equal to 900 divided by 4 pi into 15 into 15. 15 ones are 15 60s are 15 ones are 15 fours are 4 and 4 got cancelled and I got 1 by pi. 1 by pi. 1 by pi, what is the unit that I have to write, children? 1 by pi centimeter per second. 1 by pi centimeter per second. This is the answer for this sphere problem at which the radius is increasing. We are done with this. We go to the next sphere problem. That is, we go to the next sphere. The radius of an air bubble is increasing. Radius of an air bubble is increasing. What is increasing? Radius. So dr by dt is equal to question mark. Oh, radius of the balloon is increasing at what? At half centimeter per second. At what rate is the volume of the bubble increasing? dV by dt equal to question mark. When the radius is 1 centimeter. when the radius is 1 centimeter. So we'll start off with the volume formula. dr by dt is given to us. Volume of which figure? We are talking about the bubble. The bubble implies it is going to be sphere. So volume of the sphere is 4 by 3 pi r cube. dv by dt is equal to 4 pi by 3 into 3r square into dr by dt. dr by dt is given and r is given as 1. So dv by dt at, I can say, dv by dt when r is equal to, here 3 got cancelled, is equal to 1. We have got 4 pi into 1 square into dr by dt is 1 by 2. 2 ones are 2 twos. So it's equal to 2 pi. And we are talking about which one? Volume. So dv by dt is 2 pi cc per second, centimeter cube per second. Now this was a very simple problem where we are discussing about an air bubble which is a sphere. Okay, we go to the next question which is also of the sphere. Yes, it's like this. A balloon which always remains spherical. Okay, now here we need to do a balloon which is always remaining spherical, which means we are talking about sphere, has a variable diameter. Diameter is changing. 3 by 2 into 2x plus 1 is the expression that they have given, has a variable diameter. For the diameter they have given this. Find the rate of change of its volume with respect to x equal to question mark. So we are talking about with respect to x. So let me write always remains spherical. Diameter, variable diameter is equal to 3 by 2 into 2x plus 1. Find the rate of change of its volume with respect to x. dv by dx equal to question mark. So we'll start off with the volume of the sphere. V is equal to 4 by 3 pi r cube, and here they have given an expression for diameter. So this diameter tells you that r is equal to d by 2, diameter by 2. So half of this, so it is 1 by 2 into 3 by 2 into 2x plus 1 is what is our radius. So I'll come back, I'll replace for radius. V is equal to 4 pi by 3, r is 3 by 4 into 2x plus 1. Now replace for r, it is having cube, so it is whole cube. So dv by dt is equal to, I'm differentiating, dv by dx, is it not? dv by dx is equal to 4 pi by 3 constant, 3 by 4, 3 cube by 4 cube is constant. And this 3 cube and 4 cube I'll write like this: 3 into 3 square, 4 into 4 square, and this I'm differentiating 3 into 2x plus 1 whole square. Power differentiation come inside. For 2x it is into 2. So what all is getting cancelled? 1 3 1 3, 1 4 1 4. Then I have this is equal to pi is there, 3 square is 9, and 9 into 3 it is 27 pi. And what else you have? You have 2x plus 1 the whole square. This is 16. 2 divided by 16 will give you 8. 2 8 is 16. This is our final answer. And what is this? We are talking about volume. So this is centimeter, I'll say cubic per cubic units per second. This is your answer. They have not given any parameter for this. They have not given any unit for this, centimeter or meter or whatever. So I've called it as cubic units. Is the answer for what? And here in this particular problem, since they are given with respect to x, they have given the diameter also in terms of x. So we have done the differentiation with respect to x, and that is why we don't have dx by dt or anything here. This is dv by dx. We have done the differentiation with respect to x. And then we go to the next sphere problem. Here, find the rate. See the next one, and please try to do it even before I do. A balloon which always remains spherical. A balloon which always remains spherical has a variable radius. Find the rate at which its volume has a variable radius. Okay, find the rate at which its volume is increasing. dV by dt, not dV but with respect to, is increasing with the radius. With the radius. That's why they have told dV by dr. That's why they are telling it is variable radius. dV by dr is equal to question mark when the latter is 10 centimeter. This is not later, children. This is latter. In English, whatever you say, former and latter. So here, the former thing what they are discussing about is volume, and the latter thing whichever they are discussing is about radius. So they are telling when latter is 10 centimeter, when radius is 10 centimeter. So let us start off with volume. Volume of which figure? Sphere. Volume of sphere is equal to 4 by 3 pi r cube. dV by dr is equal to 4 pi by 3 into 3r square. Once again, there is no dr by dt. 3 will get cancelled. Which has a variable radius. Oh, that's all, children. So we got dV by dr, and basically here this is one note point what you should understand, that when you differentiate volume of a sphere with respect to radius, you always end up getting the formula for surface area of a sphere. See, 4 pi r square. 4 pi r square is the formula for finding the surface area of a sphere. And this is about, we have spoken about what, which all figures? We have spoken about cube, we have spoken about circle, we have done problems on sphere and one rectangle. Let's go to the next one. You have one ladder problem here. There is only one ladder problem in your book, and this ladder is all about the right angle triangle. And this is one of the points which I want you to put inside the synopsis. Okay, I wanted to put this inside your synopsis where all we have written all the formula list. Go back there. So when you say whenever you have a ladder problem, you are going to use Pythagoras theorem along with Pythagoras theorem inside a right angle triangle. Because how is the ladder kept? Ladder is always put, it is put in such a way that it is leaning against a wall and a floor. So here I have a ladder which is of length 5 meter long. He is leaning against a wall. The bottom of the ladder is pulled along the ground. So the bottom of the ladder is pulled, so the bottom is moving at a certain rate. I'll call that bottom length as x. And then what happens? The upper height on the wall at the rate of 2 centimeters per second, how fast is the height on the wall decreasing? Once they are telling decreasing, you are supposed to get a negative value. So let us see. A ladder 5 meter long. I am taking a ladder. Let AB be the ladder. The ground length I'll call as X. The height on the wall I'll call as Y. And I'll call this as O. Now what is all that they have given? A ladder is 5 meter long. So let us write, let AB be ladder which is equal to 5 meter. The bottom of the ladder is pulled along the ground, which means that dx by dt at the rate of 2 centimeter per second. 2 centimeter per second. And in this particular problem, I would like to particularly tell that according to the answer in your NCERT textbook what they have given, here the data is, when the question is wrong, there is some printing mistake, this is 4 centimeter. And all the parameters what they have given to you, it should be in terms of one dimension, either meter or it has to be centimeter or meter. See, this is 5 meter. Uh, the ladder is 5 meter. So you can make this as centimeter or this as meter. I think that would be better, no? I'll convert this 2 centimeter as meter. I'll say this as meter, suppose. Okay, if this is so, if there is a mistake, it is like this. I'll do the problem. Later on, in case they have given properly this as centimeter and this as meter, you are going to convert everything into centimeters or everything into meters and then only do the problem. So your 4 meter would have become 400 centimeter in case you want to write everything in the same. As of now, I shall take that as 2 meter because ladder also is in meter. So I'll say this is 2 meter per second. And then what is that they're questioning about? The height on the wall, how is it decreasing? Dy by dt is equal to question mark. When the foot of the ladder is when x is equal to 4 meter away from the wall. Let us write everything in meters now. So now I will break the page into two parts. They are telling x is equal to 4 centimeters, but I have two lengths over here. One is x and one is y. So let me take the Pythagoras theorem. X square plus y square is equal to 5 square. I need to differentiate this. But then I need to find out x square plus y square is equal to 5 square. When x is equal to 4, what is y equal to? So 16, if x is equal to 4 implies 16 plus y square is equal to 25. So y is equal to root of 9, and hence you got y is equal to 3. I got 3. So let y be equal to 3, and they have given x is equal to 4, and now I can differentiate this. This will be 2x into dx by dt plus 2y into dy by dt is equal to 0. So now 2 into, I'm plugging in all the data. 2 into x is 4, dx by dt they have given us 2 plus 2 into y we have got as 3 into dy by dt is equal to 0. So what is your dy by dt, that is height on the wall, how is it changing? Dy by dt is equal to 2 into 4 into 2, I push on the other side, it will be minus 2 into 4 into 2 divided by 2 into 3, 1 2 1 2 got cancelled, and you end up getting minus 8 by 3. Minus indicates that it is decreasing. Minus 8 by 3 meter per second. In case if they have given purposefully, if they have given one in centimeter and 1 meter, you are going to change everything into centimeter or everything into meter. Then only do. Everything into meter would be better because centimeter will give you huge number. Meter gives you some decimal number. You can use your calci and do if it is a board examination. Okay, that was about the rectangle problem. All right. So with this, I shall come to the end of this session. We are done with all the sphere problems, with all the cube problems, and we have done ladder problem, and we have done circle problems. Please revise on this. I'll get back to you in the next class and we'll complete this rate measure chapter. Thank you, children.